Perfect, wonderful. So I hope everyone is now refreshed and caffeinated for our next session. So here, it's my pleasure to welcome you again to this session titled Generative AI, a Game Changer for Climate Action, as part of the third symposium of the AI for Industry, Science and Society session. Again, my name is Celine Kyra. I'm an economist at the OECD, and it really is my great pleasure to be moderating this session for you today. I should mention that today's session has been convened in partnership with experts from the Global Partnership on AI. We have some lovely experts here today with us, Lee and Nico, the OECD, as well as the University of Geneva. So thank you again to our hosts at the university for the kind and warm welcome. So by way of housekeeping, today's session will be interactive, so we encourage you to participate using the Speak Up app, and you should have received a QR code along with the map of the campus, or by doing it the old-fashioned way, raising your hand, and we'll bring you a mic. So start thinking about your questions for the Q&A, and I think Nico really helped to set the stage for us with his excellent keynote. We will also be recording the session today, of course, with the consent of the panelists, and we'll make the recording available after the session. So we've assembled an exceptional lineup of speakers you see here today, so really let's get to it. We'll do a little bit of scene setting, and I'm joined here by Johannes Kierenberger, who's a consultant on AI and climate, and we'll present to you some trends that we've been seeing in the past few years around the environmental impacts of AI, and really try to get to this question of, has generative AI changed what we're seeing when it comes to climate impacts? So I'll invite Johannes to come up on stage with me here today, and we'll get started. So as we all know, and we heard some applications from Nico already, AI applications are enabling sustainability solutions. We have digital twins, carbon-aware computing, and climate trace are just some examples of initiatives. But we also must ask, are all AI applications green? So here, we have AI applications for resource extraction. It consumes, training AI models are quite energy intensive. And there's also the problem of induced demand, or what we call rebound effects, or Jevons paradox, that can make quantifying the true impact quite tricky. There are notable technology use cases specifically for energy grids. And so as Nico also mentioned, digital twin simulations, AI is very good at crunching data, mass amounts of data. So to simulate the future. Smart meters already for tracking energy consumption, and virtual power plants. Toshiba is doing some interesting work on this, and to integrate the renewable energy supply and leveraging AI and Internet of Things. So why is this a problem? Why do we need to be paying attention to the impacts of the potential impacts of AI systems on the environment? And this graph, I think, sums it up. And so, in about 2010, we had the advent of deep learning. And you see here that the estimated compute used for training milestones, so these are, big machine learning systems, has increased exponentially from about 2010. And so, as these systems are requiring even more compute, they also require more energy, more water, more resources, and we'll get into that a bit more during our panel. And this raises sustainability concerns. And so to talk a little bit about the challenges here, I'll invite Johannes to come up and take it from here.
Thanks, Celine. So I'll walk you a bit through our thinking on the environmental impacts of AI. And first of all, some recent headlines. What we see here is the dirty secret of generative AI. We have the fact that ChatGPT appears to be quite thirsty. There's some proposed data center legislation, some energy efficiency acts on the German level, on the European level, and really a lot of questions about the carbon impact, the energy impact, the water impact of AI in general. Hearing all this or seeing all these headlines, let's first put a few things into perspective. So there's a paper that was published in Nature, I think last year, And on the left side, you see that you put the ICT sector, the entire ICT sector, not just AI, but all of information and communication technology, is about at 1.4 to 3% of global CO2 emissions. That paper puts it a bit on the lower bound, but it's roughly in that ballpark. And within those 1.5 to 3%, of course, AI is only a fraction of that. So all of ICT and AI as a fraction. Just compared to that, the global aviation industry, also depending on who you ask, but is it around 2.5 to 3%? So we're in a similar ballpark. And that is not to say that neither of them are important, but to the contrary, it's of course important to decarbonize both sectors. But we're talking about a fraction of of global CO2. Just to put things into perspective, when you hear very, very loud and very noisy claims about the environmental impact and the carbon impact of artificial intelligence. Now, how big exactly is that footprint? How can we quantify it? On the left, you see a paper from I think 2019, which was one of the first to put forward some actual numbers. And it estimated the carbon emissions of training one single AI model at roughly 5 times the the full lifetimes of an average American car, which like when you just look at that picture looks quite significant. Now that paper had to do a lot of generalizations because there's very few actual data points out there. And then some researchers at Google took their transform model and their actual data. And what they found is that the emissions estimated in the 2019 paper were off by a quite significant factor. And they put it at 100 times, 100,000 times. That is not to say that the original paper was wrong or was completely off. They just had to do a lot of generalizations. And this is to illustrate that when it comes to the environmental impact and the carbon impact of AI today, the evidence is largely anecdotal. There's a big data gap and a big measurement gap, which is why the OECD jointly with GPI set out to, first of all, to do a stock take of what's out there in terms of measurement and to fill and close that measurement gap, as Nico put it in the keynote. We presented the report at COP27 last year, also together with a great expert panel, and we'll probably hopefully do a similar event this year, more on generative AI. Because the big question is, and before I'll walk you through the framework, but the question is whether generative AI has changed our analysis. We've seen that framework before. We categorize impacts into direct and indirect impacts. On the direct side, what that means is the direct impact from the AI compute lifecycle, starting with production. And when you take a typical example, you take a server rack, one of the parts of the AI compute stack. You have to extract raw materials, assemble, manufacture, then the server is transported, which has its own carbon footprint, environmental impacts, into the operation stage, which is kind of the main focus of most papers, of most research. The energy consumption, the water consumption, and the associated carbon footprint. And then at the end of the life, you collect, ship, dismantle, recycle, hopefully. That is to say, all of these 4 phases have not just carbon, but you have a lot of other environmental impacts, toxic pollution. The raw material extraction is its own story. And we had that excellent question before, asking about the whole life cycle, not just the energy consumption when training. And like at best, you include inference, but we should be talking about the entire life cycle. Then on the indirect level, you have the positive impacts, all the amazing applications we've seen and heard about in sectoral for climate mitigation and adaptation, for environmental modeling and forecasting, but also the negative effects. Lean touched upon a few. In harmful sectoral applications, you have carbon leakage problems and change of consumption patterns and rebound effects. All of this led to us having kind of we identified 5 key points for policy action. And the first one is a classic OECD one: measurement standards for sustainable AI are needed for all the reasons we've outlined before and to allow for comparability between countries. Second, the data collection. once we have those measurement standards on the impacts, should be expanded. And also what Nico said before, the key problem here is that AI-specific measurements are difficult to separate from general purpose compute. So we very rarely have actual numbers. Google put forward some 15% of their energy-related emissions are due to AI, but that's just one data point, and it's really hard to say what is AI and what is general purpose compute. Third, we need to look beyond energy use and greenhouse gas emissions to include water, but also the entire life cycle, as we discussed before. And there are more efforts for transparency and equity. Now back to the original question, also the question of our panel, does generative AI change our analysis? And what we're already seeing are some quite promising applications of generative AI. One of them we'll hear more about later, Chat Climate, using generative AI to kind of go through the vast body of knowledge that's out there on climate action and biodiversity and all other environmental aspects, and make them digestible, make them accessible to more people. And you already have the summary for policymakers, but also the summary for policymakers, I think, has like 30, 40 pages. So there's definitely some opportunity to make this more accessible. And then also, we recently asked the OECD, we asked the G7 about the top 5 opportunities of generative AI. And climate action actually ranked quite high. So 5 of the 7 countries named climate action as, in their top 5 for applications. That is the one side. The other side is that there are, let's say, some early concerning signs of generative AI. So for instance, there was a report about the water consumption, and actually Microsoft had a 34% increase in water consumption just last year. Again, hard to pinpoint, is that only generative AI? Is that AI? Is that general purpose compute? But generative AI seems to play a big part in that increase. On the right-hand side, there was just a kind of a thought experiment, that's not actual data, but a thought experiment. If billions of users would use generative AI, then the carbon impact of hardware manufacturing and model training would actually kind of recede in the background, and the big chunk of emissions would go towards inference. That is, of course, not yet the case, and you need to take this with a pinch of salt. But just to say that these questions are out there, and we need to monitor how the data develops as generative AI becomes more widespread and proliferates. We also asked ChatGPT itself how much energy it takes to run some of the questions. Unfortunately, the answer is not very conclusive, because the answer was it depends on several factors, which is what we're always finding. But it underlines the need for more data points, for more benchmarking, for more measurement standards, so that eventually ChatGPT can answer that question a bit more accurately. With that, I'll hand it back to Celine to kick off the panel.
Great, thank you, Johannes. And just to mention, that report is now public. It was published last week under the Japanese presidency to the G7. And just to say that you can find the report launched last year at oecd.ai/footprint. And with that, we'll get into our wonderful panel discussion today. So I will transition here. This is working perfect. I'm really thrilled because we have an excellent lineup for you today. And I think Johannes has done a great job of setting the scene. So just by way of introducing our panel, here to my left, we have Markus Leopold, professor at the Department of Banking and Finance at the University of Zurich, and also visiting researcher at Google DeepMind. Beside him, we have Lee Tiedrich, Distinguished Faculty Fellow in Law and Responsible Technology and Executive in Residence at Duke University. And as you may know by now, also one of the co-chairs of the GPay project RAISE. And then we have Nico, who you're all familiar with already from a fantastic keynote this morning, founder and president of the Future Society, and also GPay RAISE co-chair. And last but not least, we have Babak Falsafi, president of the Swiss Data Center Efficiency Association, and also professor at the Federal Institute of Technology in Lausanne. So thank you all today for joining us. Maybe just to kick things off, I've introduced you only by title, but really we want to get into, what your work substantively is in this area. So maybe we can just do a quick tour de table where you can introduce yourselves and mention how your work relates to the topic at hand. So maybe starting just here with you, Marcus, and we'll go around.
Well, thank you very much for inviting me to this panel. So, as you have said, I'm a professor in mathematical finance, more or less, which might sound a little bit strange, that I'm now doing generative AI and sustainability. But the fact is that, after almost 15 years teaching mathematical finance to investment banker generations, I thought that I should do something more meaningful and switch to sustainability. That was, I think, around 2015. And then I really got the chance to join a large tech company as a visiting researcher at the time when there was the real revolution in natural language processing, which was the introduction of transformers. And then I soon recognized the potential that these kind of methods can actually have, because most of the information that we have is basically unstructured information. And in order to tackle climate change, we really need to make this information usable. And that was then my journey that started in this direction. And over the years, of course, I also was looking into generative AI, because that's, as we will see, quite a powerful tool. And along this way, we created Chat Climate, and in the meantime, also other tools that we all open source and make available for everybody.
Thank you. So I'm Lee Tiedrich. I'm currently at university, and I'd say probably to sum up my work, it's really trying to bring together the multidisciplinary perspectives. Just a little bit about me. I studied electrical engineering in undergraduate school and then went to law school and practiced law for 30 years with the global law firms. Academia is kind of new to me, and trying to bring the multidisciplinary perspective to the students. So like I designed an ethical tech practicum within Duke, where I have graduate students from across the university, engineers working with lawyers on real world ethical tech issues. So some of my students work with Celine and Johannes last year on some of the OECD work on AI and climate. And then in addition to Project RAISE, I also lead the Intellectual Property Committee within Global Partnership on AI. And a lot of our work there is focusing on one of the challenges that Nico really emphasized today. How can we facilitate voluntary data sharing? Because we're not going to be able to optimize the solutions unless we can get access to the data in a responsible and trusted way.
Hi, everyone. I won't repeat what I've said before. Maybe 2 points that are relevant to this conversation. Number one, the work of TFS on AI governance now focuses exclusively on the governance of general purpose AI systems, meaning foundation models, and particularly the way in which they are designed, researched, developed, and deployed. So we have quite a bit of expertise on that, or we're trying to have, number one. And number two, before starting this organization, I worked for 10 years in India. So the context of a development is something that is dear to my heart. I've invested part of my career there, working for high-tech industry at the intersection of how we use tech and how do we do that respectfully of privacy and other constraints. I was, for example, involved in developing humanity's biggest database in the field of biometrics as part of Project Adar. It's a database, multi-biometrics, with 1.2 billion people on it. And therefore, it raises a number of questions in terms of ethics and responsibility. And as part of TFS, we've also been quite involved in trying to create a pathway for a set of national AI strategy to be developed in Africa. We've worked in Rwanda, in Ghana, and in Tunisia with Smart Africa with the same goal. We need to empower these countries to come to the table of negotiation, ready and prepared with needs of their own, with goals of their own, so that we avoid repeating the mistakes that we did collectively as we negotiated and delivered on the Paris Accord, where we put commitments on the table in terms of transfer of technology without the capacity and the means from the global south in terms of demanding access, in terms of access to these technologies.
Thank you. My name is Babak Falsafi. I'm the president of the Swiss Data Center Efficiency Association, where we provide precise metrics for measuring energy efficiency emissions in data center operation. We were cited by a report from the International Energy Agency last year, which compared all the metrics that are out there, all the certifications for data center efficiency and emissions. And they cited us as the only label that's available out there with precise metrics and ranking of energy efficiency in data centers. I'm also a professor of computer science at EPFL, the Federal Institute of Technology in Lausanne, in Switzerland, and founder of EcoCloud, which is a research center looking at both sustainable IT, how do we build data centers ground up from algorithm all the way down to electricity and cooling, which would lead to sustainability, and also IT for sustainability, where we look at how IT can help improve sustainability as a goal, as a general goal.
Fantastic, thank you. So now you've seen that we've really assembled a stellar panel here. So let's get to it, and maybe let's start with the fun stuff. Let's start with applications. So when it comes to generative AI specifically, this is a technology that or an application that undeniably has captured the world's attention in a way that perhaps many did not expect. ChatGPT becoming the fastest consumer application, the fastest growing consumer application in history. Some analysis coming out saying that generative AI could contribute a remarkable 7% increase to global GDP over the next decade. A lot here, but what does it mean for climate action? So let's look a little bit at what tools have, when it comes to harnessing generative AI, what generative AI tools have emerged, what applications are being harnessed for climate sustainability, and maybe let's just start with Marcus, because I think you've touched on one that's really interesting. So let's start with your generative AI application.
Well, I've been using kind of this large language model, so foundational models. If you think that the BERT model is also a foundation model, then we started working with that already back in 2019. But of course, more recently, or let's say since October last year, all these generative AI tools, GPT-3, they really opened up a lot of new research ideas. And I don't know whether you remember 25 years ago, there were these two crazy students from Stanford who put their homepage online with the mission to organize the world's information and make it universally accessible and useful. And the company name was Google, right? And this has totally disrupted the way how we access information. But the problem with information is that it's kind of linear and cumulative, meaning that eventually we are drowning in the information, right? So what we need is we need to put these pieces of information together so that in the end, we have the relevant information and also the information that is decision useful, not just useful, but decision useful to take action. And generative AI, if used correctly, is actually a great tool to make a narrative around these pieces of information. Because information as such doesn't carry any meaning. It's just the narrative that includes these pieces of information that obtains finally a meaning. And generative AI is actually a great tool to create this kind of narratives. And this is one of the ideas we had with Chat Climate. So our idea was, well, actually I have to admit, I never read the IPCC reports. from page 1 to page, I don't know, 10,000. And I don't know whether you did, but wouldn't it be great if we had a tool that if we have a pressing question, we can ask the IPCC report, which probably is the most authoritative source when it comes to climate change, and we get an answer, and we get an answer that is traceable in the sense that we also get the references from which pages this answer is synthesized from. So we can do kind of fact checking. And this was basically the main idea with Chat Climate, which we put online early this year, sometimes in spring. It got a lot of reaction. And since then, we developed these tools even further, because one big problem in climate change is, of course, also fact checking. So currently, let's say 3 years ago, I was working on climate related fact checking. We created a database which we called Climate Fever. Fever stands for fact evaluation and verification. And, you know, generative AI revolutionizes how we do fact checking. I don't know whether you know this web page is like climatefeedback.org. There you have a claim from probably Fox News, which is usual a suspect to distribute false claims. And then you have a climate scientist who takes a lot of time to write a short essay using references and making an argument whether this claim is actually correct, misguiding, or partially correct, or whatever. What if we have like a generative AI tool that is based on lots of different texts, like an IPCC or all climate science articles, or climate science articles from the most respected climate scientists, and aggregate this information so that we eventually can make a fact checking with all the resources and with all the reasoning behind the verification of the claim, and this within 30 seconds, right? So there's enormous potential in this direction with generative AI. And, you know, I come from financial economics, and information, this is something we learn in economics classes, is a fundamental ingredient into how markets are working, how efficiently markets are allocating capital where it is the most needed. And in my view, climate change is actually an economic problem. Okay, one can argue everything is kind of an economic problem, but you know, we need to allocate capital at the right places, and we need to know where we need to allocate these things or the capital. And therefore we need information and we need transparency. And today's corporate world is so intransparent that with these tools, we can increase this transparency that is needed for finance eventually to transition to a more sustainable economy.
That's great. Thank you for that, outlining that really interesting application. I think when it comes to various groups exploring the applications of generative AI, we know that Project Raise at GPA, as Nico walked us through this morning, is considering a variety of applications to accelerate climate action. So I just want to turn to you, Nico and Lee, as co-chairs. Have you come across any other applications that you think are particularly useful for climate action, or maybe even your personal foresight of what's coming down the line? Are there applications we haven't even started thinking about?
Thanks, Lean. Before we get there, I wanted to just circle back to something really important that Marcus said. And it comes down to we need nomenclature in terms of what is generative AI. And I think a lot of people out there in the popular press think generative AI equals ChatGPT or equals Bard. And, there have been reports about those applications hallucinating. And, if you listen closely to what Marcus was describing, we're talking about a very responsible generative AI application with a lot of site checking. So I think when we think about, how can we leverage generative AI, it's thinking about looking beyond some of the commercial applications, but how can we support great research like we just heard about from Marcus that has all those responsibilities and site checks built into it. A couple other areas that I've heard about that I think are really promising in terms of generative AI is the area of renewables. For example, if we can deploy generative AI to figure out how to develop renewables more quickly, how can we scale them? We could get to net zero perhaps a lot quicker, and then also leveraging the generative AI tools to figure out how to deploy them. Where should we put the wind farms? Where should we put the solar farms so we can optimize the yield? How can we deploy that so it can have the greatest amount of impact? Other areas where I've heard generative AI holds great promise is even in building designs and urban planning. How can we design the buildings so they're more more efficient from an energy perspective? How can we do urban planning so it's more efficient and we can reduce the impact on biodiversity loss? And another quick one I would just mention is materials. How can we design materials again that increase our energy efficiency, and on the back end, like thinking about the recycling as well. How can we put things that have already had one life, fostering more of the circular economy? So, kind of where I stand is we need the safeguards, we need to encourage the responsible applications, but there's enormous potential out there for generative AI to help achieve our climate objectives.
Well, at some point, I think, and I'd be very interested in understanding more from Marcus, how you're actually leveraging BERT as a technological pathway as opposed to generative pre-train or fusion models to actually get to a level of robustness in terms of fact-checking that enables confident, trustworthy deployments on these intersections. That's important to show that there are pathways to a robustness where these models do not necessarily need to hallucinate as they are in some commercial application. And for the similar reason, I think it's important to, when we think about generative AI, to think beyond transformer architecture. They are right now extremely powerful. They have attracted a lot of investment, but they are not the end of the underlying technoscientific cocktails, number one. Number two, I prefer to talk about general purpose AI systems as opposed to generative AI, because in my opinion, generative AI is one key function of these general purpose AI systems, but there are other key underlying functions which are extremely important to enable climate action, such as planning and reasoning, for example, that are exhibited in a generative way, but not necessarily only through those functions. The one application that attracts my interest, and I would like to quote as an example, what NVIDIA is putting on the table with this forecast net. Leveraging these foundational models and trying to have these foundational models engage with better and deeper understandings of the laws of physics, and using that in a way that can really help advance a revolution in climate modeling and moving from climate modeling or climate simulation to climate emulation. Jensen Huang, the CEO of NVIDIA, presented a vision for that at EVE Summit in Berlin. EVE stands for Earth Visualization Engine. Is the vision for super advanced digital twins. If we put the caveat that I put in my keynote, which is avoid techno-solutionism, put safety and robustness at the center of that, I think that the generative abilities of these models to simulate at a lower cost a number of scenarios over complex phenomena, renders this holy grail of moving in the direction of having like weather forecast type prediction and engagement with climate simulation, not in 15 days like ECMWF is doing, but in 15 years, serving as an immense policy planning tool to deliver on our strategies to adapt and mitigate. I think that generative AI as an underlying function and the general purpose AI systems can, I think, really advance that. There is a project that the European Commission has put on the table, Destination Earth, to serve as a catalyst to that. NVIDIA as a key really infrastructure provider within the value chain is trying to answer that call. It's not perfect, but I think that's if we can really deliver responsibly on this vision for digital twins or Earth visualization engine, we are going to be able to run on top of them really interesting and powerful tools that will revolutionize prediction and enable societies to mitigate and adapt to climate action. For me, it represents and remains some form of a holy grail. That's why we need to look at them with humility, with caution, and not fall into the risk, the trap of techno solutionism. That's the one, a set of applications that are attracting my attention. Thank you.
That's great. Yeah, Babak, or I was going to ask you a question about direct impacts, but if you also have thoughts on applications.
We can go ahead and I'll bring my answer into the next question.
Sure, that's great. So we kind of covered, some really nice examples of applications of generative AI systems and AI systems more generally. But let's also talk about the direct impacts. And, this is something that has come through in the presentation. So the direct impacts of actually producing and training a model, doing the inference. The classic AI production function has data, algorithms, so software and compute. Let's talk about the compute that is run with the computing stack, which includes data centers, of course. Just to give one number, I think some estimates were that GPT-4 cost about $100 million to train, right? That's just one example, but these models are becoming bigger, and I think we have to ask the question. So my question to you, Babak, is are we seeing what trends are you seeing from the perspective of data center efficiency? Does generative AI use exponentially more compute? And also interested to know your thoughts on whether now we're seeing inference becoming more significant compared to training. So why don't we start there?
Thank you very much. So first of all, let me go back to the first question. I like a point that Marcus pointed out right from the beginning, which is that we're looking at an economic model. The problem with carbon emissions is that there is no economy. We don't make anybody pay for carbon. Right? That's the thing we need to think about if we're thinking about metrics and we're thinking about economic models, right? That's a fundamental problem. It's not just an IT problem, it's a problem in all sectors. So that's something to think about. And that includes, by the way, chips that NVIDIA and all the other computing companies sell. The second point I want to bring up is that the introductory presentation, there was this controversy between two graphs. There was a graph from MIT Tech Review, which says in 2019, searching for or training a large AI model is 5 times the size of the life cycle emissions of an American car. Americans drive huge cars, so that's big, much bigger than ones in Switzerland. And then the other graph on the side said Dave Patterson, who was an Turing Award winner and now at Google, so he's at Google. Okay, he's no longer at University of California, Berkeley, saying that, well, no, that's not, don't worry about AI because these numbers are a little exaggerated. It's actually going down. So there is truth in both of those. First of all, generative AI does not mean that you need the largest model to train. Okay, so AI is plateauing in some sense in terms of the size that you need to put to use for every sector of the society. So it's not like we have to train a large model every time. But if we do go train one of those large models, then yes, the emissions are really, really scary. Okay, so that's one thing to think about. The other thing is that it is also true that the computational needs, they move as you train models, they move towards inference. Now, there are no metrics or there's not enough data to point that out. That's still an open research question, but we see that in industry today. We see that there are a lot of sectors in the society, in the market, where we don't need, we're reaching basically diminishing returns in training the models, and many of these mid-sized models are already applicable and are put to use in our work. So that's good. Now, let's talk about one thing that nobody talks about. Computing is done through silicon. Okay, so silicon are these little things you don't see. This is actually my area of expertise because I design computers. So, you have a little chip in here that does your computing. You have it in the data centers. And this silicon followed a density growth path, which gave us computing for free for several decades. This is called the Moore's Law. And this was taken after one of the founders of Intel. He recently passed away, Gordon Moore. And for several decades, through lithography, through printing tiny miniature circuits and making that smaller and smaller and bringing the electrical consumption of every little element down exponentially, we could double the density every 2 years. That's about 40% per year of silicon density. That means that if you go from 2005 to 2015 in 10 years, without you doing anything, your rack would become 30 times denser. Okay? Now, every exponential comes to a halt eventually. This one took a long time, many generations. So now we're seeing density growth at around 10% a year. And this will eventually soon stop. That means that if you want to go from 2015 to 2025, 10 years, same rack, you're going to get only 4 times denser. So if you want to continue the same growth, the 30x that you saw in the first 10 years, you have to build 7 times as much. That means more chips. If the chip is not getting denser, you need more chips. So that's more embodied carbon for the chip, but also more chips that are operating at the same time, right? So that's just fundamental laws of physics. We cannot do anything about it. It has nothing to do with economy either. It's just the laws of physics. We cannot make it denser. So we're going to build a lot more. So that means more embodied carbon, more operation. Now, another little important piece of information. Because this density is not happening magically, we can no longer build general purpose computing platforms. That means that to be able to improve the use of that silicon, we have to specialize the designs for certain types of computation. So you reduce less silicon resources and do other things with your limited budget that you're getting. That specialization may mean that we now have to turn around those chips much faster than we used to. Okay, so that's something to keep in mind as well. So that accelerates embodied carbon because we're generating more chips. Last but not least, this, by the way, we're seeing this trend with NVIDIA, and NVIDIA is the only company that's making GPUs. I mean, their stocks basically tripled since January, okay? AI is really good for NVIDIA. AMD is the other company that makes GPUs. They've been behind. Their stocks only doubled in 6 months this year. So I think that the hyperscalers are going to start negotiating a deal between AMD because NVIDIA is basically charging line pricing for their chips, right? So there has to be more competition to make this work. But none of this has any economic model for paying people to pay for carbon. That's really the only thing. So what we need, obviously, and what we can do here is to create metrics and clarity about what's going on.
I think that's a great segue into my next question. Measurement. How do we actually know what's going on? We've, as was illustrated, there's been research, lots of research at the model level, trying to quantify, specific model resources required. How do you go about, providing some sort of calculation at the national level? Do you add up all the models in a country? How does it work with cloud that knows no borders? Do you want to respond to that?
Well, so I mean, I come from, so my other hat, I mean, my primary hat is EFL, the other hat is Swiss Data Center Efficiency Association. We started with data centers, because data centers are the pillar of computing today. Everything is backed up by data center. And we said, okay, let's look into metrics for data centers. The metric we use today for data centers is called PUE, Power Usage Efficiency, which accounts for what fraction of electricity goes into everything but computing and storing data in the data center. And that used to be pretty high because we didn't have technologies to cool and back up our data centers, our computes 20 years ago. That was, by the way, the metric that Google started advertising PUE 20 years ago. PUE was high. It was 2. That means 100% extra overhead just for the building and the infrastructure around it, not for the compute. Now PUEs are around 1.3 in Switzerland. The new constructions are 1.1. That means that most of the electricity you're delivering is going to the compute, is going to the server. It's not going into the building. And we still use the same metric. So metrics are important. So we started this the STA label by just looking at metrics. We have a full stack metric for not just the building and the infrastructure, but also the servers. We have the first set of KPIs for the server. Metrics are good, but we also need technology to be able to measure them. For electricity flow, for water flow, we have counters. Those are built in the building code. For servers, we don't have the proper instrumentation technology. So we're working with partners. CheckMK is a company in Germany that allows software to be instrumented in proper places so we can figure out where we're spending the electricity in the servers. This is just the beginning. We're just the first set of KPIs out there. So.
I think that's really interesting and really great examples. Marcus, I might turn to you next on the question of measurement. I think we all liked the way you kind of framed the issue as almost a classic economic, negative externality problem. Are there measurements that can help us, bring that into the economic model and take that into I know, are there things from ESG perhaps reporting that could be used?
ESG is a terrible word, but I'm definitely not an expert on measurement. I think I have to turn to the left of me for these measurement issues. Because something I want to stress here really is that all the research that we do is basically academic research, and we open source everything. And back in 2021, so I started my career in AI and sustainability with the creation of Climate Bird at that time, which is something we use then to assess the communication of corporations and their commitments. So we created the CTI. It's not ESG, it's CTI, because in finance, you need to be successful, you need these acronyms with 3 letters. And the CTI stands for the Cheap Talk Index. And we used Climate Bird to analyze cheap talk of companies. And they, of course, have a lot of cheap talk. And the cheap talk is statistically significant for those that increase their emissions the most, which was kind of to be expected, actually. But that's a wonderful tool. And then back in 2021, we started to already look at the problem of whether we should use smaller models for some problems, right? Because, my students, they love to take GPT-4 or GPT-3 for tiny little models, right? And you don't need these models for certain problems. And at that time, we started to write the paper, which then got accepted at the EMNLP, which is a very good NLP conference, where we provide some kind of model card for researchers that do experiments with models that they should report kind of for each paper that they're writing. Report the electricity usage, depending on the electricity mix of the country that they're doing this kind of experiment, so that we, at least from the research side, we get some kind of insights about how much energy we are actually using. And if I can briefly comment on your robustness question. So we overcome this problem of hallucination by retrieval augmented generation. That is, you really have the documents that you want the language model to assess and nothing else. So we force the language model really to take information just from these models. And second, robustness still could be a problem. So that's why we open source this model. So we ask users to provide feedback so that in the next round, we can improve the model and see what the weaknesses are. And second, and I stress again, I'm a researcher and an academic, so I don't have a startup with this generative AI stuff. So we have papers that we write and where all the methodology is crystal clear and transparent for everybody to replicate. And that generates this additional robustness.
That's great. I might I want to pick up on something that's come up a few times, and that is open source. And we've seen open source happen, through platforms like GitHub for software and increasingly Hugging Face for AI models. This is something that's really interesting, and I don't think there's necessarily sufficient research in this area to understand the trends. Researchers now can download models. They don't have to train them from scratch, and they can fine tune. So that's an interesting trend, I think. Nico, I might go to you to comment on that or anything else.
I'll comment on that, but first I want to bring these 2 points together. At the beginning of starting the journey I started 10 years ago on AI governance, we put the need for measurement and metrology at the center of the infrastructure of trust we need to adopt AI responsibly. And the work I've done trying to collaborate with OECD on that, and one of the reasons why we selected OECD as a very important target that we would want to help is because of the competence and the obsession of OECD for sound, and I use this word, sound measurement, because we really need that. And why we thought we needed that pertains to both what Marcus and Babak were saying, but for different reasons. Within the realm of model development, we've got within the robustness improvement feedback loop measurement problem. Why you're resulting to the open source is because is there like an authoritative and independent high-level benchmarking of the level of robustness of the way in which the model within the framework of information retrieval deals with the document? No. We need a lot of more progress on that. And I'm thankful that you're engaging in the open source conversation there, because it's a call for action to the community to help us sort this out. But the problem that Babak is facing is different. Do we have a scientific metrology problem there? Not necessarily. We don't have the tools, we don't have the metrics, but we don't have necessarily the same magnitude of scientific problem to get to understand what is the energy consumption of AI compute. I think we have a measurement challenge to both, but we don't have the same magnitude of the challenge there. And that's why it's extremely important that one of the pillars of the emerging AI governance field is called compute governance. Increasingly, we're trying to govern the way in which we deal with compute. One of the things that we've been pushing, that's why I quoted the EU Act, is within the realm of compute governance, it is imperative that we empower Babak and people operating in that community to deliver the metrics that society deserves to reward the right actors and those who perform at the highest level. We need to create a level playing field for them to compete on the quality of the HPC that they deliver vis-a-vis the environmental impact. On that front, we don't have a scientific problem. I mean, we have scientific problems, but there we have a boulevard. Let's just deliver. We have policy solutions. Let's just deliver on that. On the measurement challenge of the robustness of model, it's not at all the same thing. We have an immense scientific problem, and it's growing. I mean, if we're talking about trillions of parameters and like trillions of tokens to deal with these parameters, I mean, the measurement challenge that we have to get to a point of interpretability, I mean, this is like it gives me vertigo. But we should not put these two measurement challenge on the same field. And so there are areas where we can and we should move forward. We don't need to wait.
So I think, maybe I'll go to you, Lee, and we can also segue into the policy discussion as I think our last theme here before we open the floor up for questions. So start thinking about your questions and posting them on the Speak Up app. But yeah, if you want to respond to that and maybe tie it in with other initiatives, how are policymakers supposed to make good policy decisions if they don't necessarily know the trends and what's going on?
I mean, I think you're hitting the nail on the head. It's very hard for policymakers to make decisions. It's hard to hold people accountable if we don't have measurement techniques. And I think one of the themes we're hearing today, and with what I hear every day of the week, is if policymakers want to move the dial on this, it's time to start funding the development of measurement techniques And, we have standards organizations and they're great, but we need to open them up and it needs to be a more inclusive process. We need to make sure that academia is at the table, SMEs at the table, have grand challenges around how do we solve some of these measurement issues. Because if we have measurement techniques, then we can figure out how to have reporting, and it needs to be done in a way where people can understand it. And you want to protect the proprietary. We have cybersecurity concerns, so we don't want companies putting out all the information about their systems because that's going to cause other problems. So how can we come up with reporting mechanisms based on the measurements? So I think there's a real call to action there to try to develop that. And open source is another big issue. And I thought the OECD report, it was the first time I've seen open source really brought to the forefront in the way that it should be. I mean, on the one hand, open source is great because it's it's fueling the economy, it's fueling development. And the G7 ministers really called out the importance of continuing to foster innovation and entrepreneurship. But, with cybersecurity, with open source comes risks, the cybersecurity risks. And in the United States, all the national security agencies are really focused on cybersecurity risks with open source. And then on top of it, you have the ethical concerns of open sourcing AI. We want to see it put in the hands of good actors, but there also are a lot of nefarious actors out there, unfortunately. And if you open source it, how can you put those guardrails in place, which kind of ties it back to the other project, on licensing, how do we make our open source models available in a way that fosters the innovation, but also has licensing guardrails, has technical guardrails, business codes of conduct, education that also make sure it's being used for good purposes and doesn't end up in the wrong hands.
Yeah, Babak. Yeah, for sure.
Quick comments on this. Regarding open source, first of all, OpenAI and Hugging Face are not open. Those models they're releasing are tiny. If you want to use the larger models, you have to pay. OpenAI is owned by Microsoft. Number one. Number two, I wanted to sort of comment on what Nico said. He's absolutely right that we don't need science to figure out how to measure electricity, how to measure water, even in our software stacks today. But the truth is, and I also agree that when it comes to ethics, we have absolutely no science, or we don't know what's going on. Only the hyperscalers, only large companies know what's going on there. They're not willing to share. So we hear different news from them. Let's put it this way. I have classmates who are in VPs in all these top companies. So now what I wanted to say was that there are no economic incentives to measure. Even though the science on my side is fixed, we still don't have economic incentives. I'll give you a little anecdote. So we have a potential customer in Switzerland. They're a co-locator. They're in this region, by the way. And their efficiencies are super low because they're in the business of selling expensive electricity to their customers, and they know their customers don't use the electricity. When you sell electricity, when you provision for electricity inside a campus, 5,000 square meters, you waste a lot of electricity supporting the cooling and distribution networks. And the customers don't even know how much electricity they're using. They're selling the area per square meter, and it's at a rate of high. So there's a negative economic incentive for them, because if they try to make their campus more efficient, they lose money. So it's also related to policy. The last thing I want to say is that all of compute in the future will be either AI or it will be data served to people or AI. That's it. So in the future, if you think about all of your compute infrastructure, you're either serving data, whether it's economic retail, whether it's search, entertainment, whatever it is, or you're doing AI. There's nothing else. So we will be building, and whatever sustainability we're considering will be for these two things. How do you serve data, and how do you use AI to analyze it?
So in the context of those applications that we're seeing appear in the market, Maybe we can touch on a little bit the responses, both the policy, the legal, and the regulatory responses we're seeing emerge from governments. One example that obviously comes to mind is the EU AI Act, and I'll come to you, Nico, on this. There is some language in there on environmental sustainability reporting, and it's in the framework of the high risk or the risk-based framework. So tell us a little bit about that, Nico.
So within this forthcoming EU Act, which has the chance of becoming a global gold standard because of the critical mass of the European market and because of the interdependence between this European market and the American providers. So we have a chance of seeing the provisions that have been put and inserted as a result of the political deal that the European Parliament's political group have managed to deliver. It's not that often that you see that vast bipartisan agreement delivering something like 500 votes on the floor on a political deal. It's not something we should underestimate, given how fragmented is a single common market in our societies. So what the text is trying to move the needle towards is trying to have the developers and the deployers of the systems being more transparent and creating the incentives to develop these metrics in terms of the environmental footprint of their AI compute. And that's why this report, so my hope is that the feedback loop between this legislative requirement and the evidence-based policymaking work that you lead at OECD and we have tried to work on together with this AI and compute report, this creates hopefully a boulevard to drill on these metrics and to get better, deeper, and more at times sincere information from the compute providers. They were not always forthcoming. They need to be more forthcoming. It's not easy for them because they compete. So it's okay for them to keep the cards close to their chest, but they need to be a bit more forthcoming. And so that's one. But there are other national laws that are moving in the right direction. There is one that has not been mentioned I want to call. The French law to move towards a circular economy that was voted, I think, in 2019 to help revolutionize the way in which we look at waste and waste management and try and bring IT within the equation is also interesting. Trying to put a number of incentives to have more transparent and high resolution information on the environmental footprint of all terminals, their components, and compute. Same logic. Legislators putting together frameworks to create a pathway for evidence-based policymaking so that international organizations and actors can then seize them and say, look, now we're going to benchmark ourselves upwards there in terms of transparency and the quality of the information. This is where I really think that international cooperation is really needed, and we need everyone to play their parts. But without legally binding regime, meaning backstops, it will be difficult to, exactly as Baba was saying, to create the right incentives, because there is a reckless race to the bottom, and because digital capitalism is digital capitalism. We need regulation on that too. Otherwise, and it's not the only thing, we also need indeed to create the conditions for the carbon market to exist and to put a price on the ton of carbon, which is decent, 30 euros, 40 euros. But we need that. Without that, we want capital in terms of incentives. We need this collective set of incentives.
I think those are really good points, and some folks in our audience have picked up on that in the questions that they've asked. So I'll get to those questions in a moment. But I just want to turn to you, Babak, for one moment. In terms of policy that we're seeing at the EU level, we have the European Energy Efficiency Directive. Just want to know, is that something you're familiar with? Is it going to make a difference, do you think, when it comes to data centers?
It's a good step in the right direction. I'm also part of that working group, and I see. So we're a little bit ahead of that in Switzerland. I think it's a step in a good direction. There is a lot of resistance to this. So we have launched our label in Switzerland, but it's a global label. I'm also in other countries in Germany and Austria, and in Europe in general, we see a bit of resistance from sort of mom and pop data center owners or machine rooms trying to move towards higher efficiency, and they're sort of resisting and against any sort of regulation. This particular report was a good report because at least it's forcing everybody to say what they own, how much electricity they're consuming, how much water they're consuming, potentially also say what they're outputting, but that's a difficult sort of challenge. Metrics, data center output don't exist. For AI, it's easier to see what the metric is because AI is it's basically a streamlined form of computation. It's mostly matrix multiply, if you will, at a sort of K-12 level. So it's easier to measure what AI is doing. But if you look at the entire data center and the various complex software stacks we have, it's harder to figure out what exactly the output of the data center. So that's going to come hopefully in the future. It's in the right step, but it's a little bit conservative. I think, for example, they require that data centers that are beyond 500 kilowatts of consumption to report. There's still a lot of machine rooms that are lurking around that don't consume at that level. Or it also basically incentivizes people to go to smaller sites, which will be less efficient, just so that they don't have to report. But from the perspective of, do we have actually a metric and clarity about what we have? That regulation is far from that at this point.
So I think certainly one to watch. Let's get now to our audience questions. So we have some great questions here. I'm going to go at it very democratically. So choosing the ones that have received the most votes. And yes, you can vote questions up and down. This is actually a question that I've received before on panels, and I think sometimes the most brilliant questions are the simple ones. So this one is kind of a question about fundamentals. So what are the technical and strategic reasons for even separating out AI-specific computing resources from general purpose computing infrastructure? Sure.
There's absolutely no technical reason. The only reason why we're talking about AI is because AI is in the news. It's literally a household name. So that's the only reason why we're talking. There's absolutely no reason. The fraction of AI in overall compute is low, but there was another report that MIT Tech Review published recently that said there was an analysis of the last 10 years, and AI is growing 6x per year in computational needs. It's still small, but it's growing much, much faster than average computation. But from a technological perspective, there's no difference. Measuring efficiency of just that AI computation that goes into AI is actually simpler than measuring the efficiency of the entire data center.
Any others want to weigh in on that question? No, that's great. And I think from our perspective as well, it's, as Babak said, the trend is increasing. We're also with the number of users and just, if you look at population projections and digitalization trends, more and more users are coming online. And so I think it's incumbent on us and policymakers to at least understand the trend. Is AI contributing to the overall emissions? What is the share to be able to, inform evidence-based policy? So let's move on to another question here. So this one is one, the concept of internalizing negative externalities, or, capturing that in your economic model. One way of doing this is through carbon tax. So our audience question here is, should a carbon tax be applicable to training generative AI models?
Well, carbon tax should be kind of a overall concept, not just on generative AI. So in that sense, yes, there should be, whenever there are emissions, there should be a carbon tax. So it's irrespective of whether it's AI or linear regression or function fitting, whatever you want to call it. Yeah.
Can I comment on that? Carbon tax only works. This is universally applicable, right? Otherwise, we saw from the Kyoto Protocol, carbon gets shifted.
That's a very complicated problem, because that's one of the reasons why it's so difficult to kickstart or prime the pump of a carbon market. It doesn't work locally, it doesn't work regionally. It has to be blanket universal, and that's what makes it so hard. And that's in a way not the tragedy of the commons, but that's why it's so hard. That's why it remains the holy grail of ecological transition in it. Yeah. And will it work if, for example, is the European Union a sufficiently large market in terms of its critical mass so that it could move forward on that? This is one of the ideas that's been pushed, that creating this carbon tax at the external borders of our market. This is one of these political concepts that has been put at the top of our political agenda for ecological transition.
Yes, and I think you look at initiatives like the greenhouse gas protocol with your different scopes, right? Scope 1, Scope 2, Scope 3, also raising the question that many experts have raised around embodied emissions. So looking up higher in the supply chain to better understand, the resource intensity of ICT infrastructure, and as Babak pointed out, the purpose-built infrastructure specifically for AI. Now I see we have a question in the room, I think, which is great. So maybe, maybe we'll start with Monsieur in the back. Yeah, you've had your hand up first, and then we'll go to Ali. Yeah, go ahead.
Thanks a lot. Maybe a question regarding the data space at the EU level, because I used to work on one, the data space for public procurement, and I know that we linked the Green Deal in the strategy with it. So I love what you said about specific scope in order to do some kind of AI. But then in the future, the idea would be to have all those data spaces connected and act as a nursery for AI in order to drive policy making. And I would like to have your view on that.
And maybe just introduce yourself as well.
Yeah, since Monday, so Simoardi, working as a consultant and as well founder of a startup, Cities AI. So thanks.
Try and take a stab at that. Yes, that's the ambition. Yes, Thierry Breton, the commissioner for the internal market, pushing for the creation of the data spaces, is ambitioning to create a unified set of data spaces, well organized, well capacitated, per element or per sector of competence and per area. That's the hope. The way in which we are going to be able to integrate those data spaces is extremely complicated for many good reasons and bad reasons. I mean, what we should, in my opinion, not want is a unified data lake, for example. This kind of things but unifying them in a way that they are bridges, number one, in the sense that they are actually serving an ecosystem, they are being maintained, and there is a positive feedback loop of use and investment, so that they are lively and they are not, because we see data spaces that are dying. Not all data repository are vibrant. Most of them are not, actually. So it's really a combination of many things, and that's the hope. Will that happen? My personal fear is that we have seen many of these great political ambitions translate into industrial crashes, particularly in the European Union, for many good and bad reasons. That's why I think we should be extremely humble and before trying to federate them, is have a few of them being delivered and actually serving communities and markets.
I agree, thanks. And actually for the public procurement data space, a pilot was created and we were able to, not us, but to showcase fraud. So the misuse of taxpayer money. And it's as well a very good way to communicate and to explain to the citizen what the EU is trying to achieve and there how to avoid the rise of populism, actually, because if we're not able to communicate, it's going to be that. And we will put a very good infrastructure in the hand of very bad people, actually. So that's one of the risks. And maybe just one other question, because regarding the capture of data, since you used to work in finance, so you know that now there is as well this very good startup. So it was created a few years ago, Parable.ai. So catching all data from unstructured documents in finance as a first scope, but this is something that we can reuse in other scope as well in order to avoid what we see as data governance expert, always starting with business glossary, etc., blah, 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 and spending a lot of time. What is your view on this kind of capture of unstructured data?
So, I mean, there are basically many startups. There's MSCI that announced a collaboration with Google Cloud on they also have lots of data. I think my view on that is that the best thing going forward is really to create radical transparency, in the sense that you should make the data available for everybody. Now, this is probably a little bit of a naive view of an academic like me, but when we don't make the data transparent, and also the methodology that has created some kind of signal or aggregation of data, then it remains a black box, right? And it seems that you are much further in terms of measuring the impact of generative AI. When you want to measure the impact of companies on the environment, you go into this ESG kind of space, and this is a really terrible space to be in, because it basically measures, well, I don't know what it measures, maybe room temperature, or I don't know, because there's so much confusion about what ESG is and different approaches, how ESG is measured. And I spent quite some time on that. And unless we do not have full transparency on how this is done, which requires also, rating agencies going a step forward in terms of generating transparency, we don't have the right useful information to make our decisions.
I think also, just to add to the good responses, is your question highlights the need that we need to put a lot more emphasis and work into data governance, because our GPay work, I'm wearing my other hat on the IP committee, touches on that. Like, we focus on how do we create the contractual tools so parties can voluntarily, responsibly share data. But you're never going to develop the European data spaces or any other data commons unless you have mechanisms in place, right, for the whole life cycle of the data commons. And sustainability is an important piece of that. As you're designing the European data spaces or any other data space, how do you do it in a way that factors into sustainability? The question of, do we have a giant data lake? Do we have more of a federated model? Thinking about who are the data contributors, what are they willing to do, right? If they're not going to make their data available in the data lake, maybe that's not going to work. Thinking about the cybersecurity issues, because that's really important too. So I think, to get to the answers of those questions and to achieve the objectives and do it in a sustainable way, we really do need to double down on data governance.
Maybe just an info that might be a matter of reassurance to your hope, rather, Marcus and FYI. There is the Climate Data Science Committee that Michael Bloomberg and Emmanuel Macron started, that now has many, many, many partners, has put a roadmap to develop a net zero data space utility as a way to create a standardized way for companies that are particularly listed to disclose ESG relevant data for climate transition along a standardized framework that is, relevant. That's so we'll see what the prototype yields, but that's the hope, to move beyond the current situation, which is absurd in many ways.
Final word to Marcus, and then we'll go to our question at the back of the room.
So just a fun fact, we created Chat Report, which is also publicly available, which is basically mimicking what a junior analyst at a rating agency would do. Take the recommendations from Bloomberg, like the TCFD requirements, read the recommendations, ask the relevant questions to corporate sustainability report, and assess the quality of the questions. So you can either do that with a rating agency, or you can do that with our tool within, I think, takes 1 minute. We are not optimized in that sense, but it's freely available, and it gets you an assessment of the corporate sustainability report on TCFD conformity, which measures how well the company massages its words. It doesn't mean anything whether it's actually doing good or not, whether it walks the talk, right? So.
Great, thank you. And you have a mic at the back of the room. Perfect. Over to you, and please introduce yourself.
Alev Mine of the One Goal Initiative for Governance. This is I would like to have a description of what risk-based versus rights-based would mean for the people making, building AI products, and also for the users and for the governments and for the regulations. Thank you.
Thanks for the interesting question. I think we're going to explore this as well in an afternoon panel through the lens of privacy, rights-based versus risk-based that we're seeing in the EU AI Act. So I might turn to our in-house lawyer here, Lee.
I think just a couple ways to respond in terms of broad framing. And then I do want to circle back to some of the policy developments in the United States that I think are also helpful here. I think from a risk-based approach, I mean, one of the developments in the United States is the National Institute for Standards and Technology has put together the AI risk management framework, which is risk-based. And it's a very, I think, well-done document. It's voluntary from a U.S. standard. And part of what the US is trying to do with the EU and other jurisdictions is create harmonization because we have different standards and practices across all the different nations. We're never going to optimize efficiency. So, one of the things that you see in the current version of the AI, they call it the AIRMF, is identifying what are the environmental risks. So it's that risk-based approach. And it's all based on having governance in the middle and then, mapping, measuring and managing risk. So I think that kind of addresses the risk-based approach. I mean, on the rights base, I think what's really interesting, we're starting to see from the United States is people are starting to say, and it's made its way into the courts, that we have a right to live in a society where the environment is not harming us. And there was a case brought, I'm going to forget the jurisdiction, but somewhere in the Midwest where it was actually a group of students, and more power to the students. And they were challenging decisions of the government to allow certain types of environmental harms to happen. So, I think in the AI discussion, we're going to be talking later about fundamental rights, more in the context of privacy, but, we're starting to see, in the United States, and I'd be interested in people's views elsewhere, that, the right to have a safe environment that protects us as individuals is starting to be recognized. And it wouldn't, and we're starting to see even like the Surgeon General in the United States is linking some of the environmental situation to health hazards. And I think it is starting to transition into more of a rights, looking at it from a rights-based lens as well as the risk-based lens. And I think that conversation should continue.
Maybe to build upon that, because that's one of the overarching point of tension at the core of the emerging AI governance. How we reconcile a risk-based and a rights-based approach, and the rights-based is in nature, looks in nature as a more absolute way of looking at things. Whatever the risk, certain rights should be enshrined forever. When you get closer to it, because the conversation is already happening and the reconciliation has already started to happen, one of the ways in which you practice rights-based governance, for example, in the protection of privacy, pertains to principles of governance that have been used and have been adjudicated over. Two of these principles, which are at the center of the practice, both in the US, or you correct me if I'm wrong, and certainly in Europe, are principles of proportionality and principles of necessity. When you look at enacting a data collection process, GDPR mandates, for example, but GDPR enshrined into law principles that were already in practice, that were recognized across the union, whether the way in which you create your collection and your processing, whether it is proportionate to the intention that you put, and whether it is necessary. Something which is not proportionate and necessary is deemed to be illegal or not right in a way. That, in my opinion, there are 5 principles, if I remember well, but these principles are bridge from the right-based to the risk-based approach. And I wish and I hope that the risk-based framework and that some of the work that the OECD is doing to reconcile these risk-based frameworks at an international level uses these principles as bridge building between the two approaches, so that at the end of the day, we have something that is both risk managed, but also tries and enshrine in practice certain rights, whatever the risks and whatever the scale of risk, high risk or low risk, if that makes sense.
That's great. I think we'll go to Alistair for our last question, and then we'll do our lightning round as we wrap up. Over to you.
Okay, this is Ali Knott from New Zealand and also from another part of GPay. So I've got a question about two other, I suppose, effects of generative AI models that haven't really come up yet. Both very global, one on politics and one on economics. So the politics one is that generative models lower the bar on production of disinformation, and they are going to, unless they are kept safe, destabilize democracies. And that is going to have an enormous impact on our ability to respond to the climate crisis. Another effect, which is also very global, we mentioned that generative AI models are going to be great at helping us to build ecological buildings or sort of smart buildings or smart cities. They're going to have an effect to help us build everything. So we're going to be able to increase our productivity and produce more stuff. And that probably also is going to have detrimental effects overall on the climate crisis. So I would like you to comment on those two very macro effects that may be much more significant than compute effects.
You're hinting at one of the things that is there in the underlying framework that Céline and Johannes built, which is the rebound effect. We need to look holistically at how we want to deploy these technologies and for what. That's why the responsible AI framework that we have tried to lay the groundwork for is so central. It's because it's not value neutral. It matters to, and Inma is going to talk about that later, AI for good. It matters how we think as to how we're going to leverage these technologies and how we impact planning and we prioritize. And this rebound effect, if we don't pay attention to that, can have extremely negative consequences. So we could discuss about the epistemic collapse that you're hinting at and how it's going to affect our ability to build upon civic epistemologies that enable climate transition. But that's for hours. Thanks.
No, that's great. I think rebound effects are quite complicated as well to measure. So a really important point there. Thanks for raising. So I think we're approaching the end of our panel. So why don't we do a lightning round? This is my often favorite part of panels. What is the one thing you want the audience to take away from today? What is your one key message? Why don't we start with you, Marcus?
Well, I think the key message that I have, which reflects a little bit the motivation for my research, is that AI, whether you want to call it generative or even if you want to call it AI, natural language processing tools have the ability to organize the climate relevant information and make it accessible for politicians, for instance, and provides then decision useful information. So that's very important and reflects a little bit what I've been talking about yesterday. So I was invited at the UNECE. They plan to come up with a platform for policymakers, and we provided the first kind of prototype for them to improve their decision finding process. Of course, all the member states agreed that this is quite useful, except one, the obvious suspect, I guess.
I guess I'll end where I started, that I think this conversation highlights not only the need for international coordination, but multidisciplinary coordination. We clearly need the scientists to inform us on an inclusive basis. How can we do the measurements? The policymakers need to understand that in order to figure out how to shape laws, how to shape reporting obligations in a way that aligns sound policy with science. And I see through, my decades of work that even within companies and corporations, as they try to tackle these challenges, it needs to be a multidisciplinary approach. The people who are designing the architecture need to talk to the legal side to figure out what the policies are. You need to be factoring in sustainability, cybersecurity. So I think multidisciplinary collaboration across jurisdictions is really the path forward.
Yeah, my closing line is we have a moral obligation and an immense impact opportunity to close the measurement gap. And in closing the measurement gap, I know it sounds boring, I know it's not necessarily the funniest thing, but that's so important to create and align the right incentives. And some of these metrology problems, as I said, are extremely complicated, represent remaining and actually growing scientific problems. Some are not. And so let's get going. Might sound boring, but it's of strategic importance to actually enable the ecological transition and to create a level playing field, as I said.
So my closing remark is that AI is just like any other form of computation. It just is growing in recent years a bit faster. We need proper metrics to measure the impact of computing in general, not just AI. SDA, our label, is a first step towards that for data centers, and includes AI. We also need economic incentives for sustainability, right? Without economic incentives, as the last question also showed, you can encourage consumerism with better products that are even cheaper, and that's not good for sustainability.
That's great. Well, thank you. I'll wrap up now our panel just with thanking our panelists today. I think we've really covered a lot of ground and really great engagement and good questions from the audience. So thank you. So just to again thank our hosts, the University of Geneva, for having us today, experts from GPay who participated, and I know we also have Sophie Falaha, Alan Paik, and Inma Martinez here as well, and of course our industry and academic experts, Marcus and Babak. We're now standing between you and lunch, so I will wrap this up now just with a thank you. So please join me in thanking everyone. Thanks.